All right, let's do one more slightly more complicated integration by parts problem. If you could do this problem, you could pretty much do any integration by parts problem. So you have the integral of e to the x times sine x dx. Well, solve it using integration by parts. So to pick your u, let's just use our Lie8 mnemonic device that we had last time. So you just go down the list. The first one you have becomes your u. So there's no logarithmic, there's no inverse trig, there's no algebraic, but there is a trig function, that's sine x. So u equals sine x du equals cosine x, and then dv is whatever's left over. In this case, that's just e to the x dx. So the integral of that, the integral of e to the x dx is just e to the x. So now we follow the formula. Recall that it's uv minus v du. Here, I'll just write it. uv minus the integral v du. So u times v, that's e to the x times sine x minus v du. That's just e to the x cosine x. Oh, there should be a dx here. Okay, so in all the problems before, when we got to this step, we were pretty much done. We just had to take the integral of something that was easily integrated. We'd simplify our answer and we were done. But now we have this as our integral, e to the x cosine x, and that's not something that's easily integrated. So we actually have to do integration by parts again. So just make a new one here. I'll write that problem again. E to the x sine x minus e to the x cosine x dx. The integral of that. Cosine x dx. Let me just see if that's right. Yep. So now we could just ignore this part for right now and treat this as another integration by parts problem. So again, you pick your u, your du, and your dv and v. So u, again, using Lie8, t comes before trigonometric, comes before exponential, so it's just cosine x. And your dv is e to the x dx. So now differentiate going down. Cosine x, that's neg sine x. And then since your dv is e to the x, your v is just the integral, which is again e to the x. So now, and again, this is just for this part, we're ignoring the e to the x sine x for right now. This equals u times v, e to the x, cosine x, minus integral v du, that's e to the x, times neg sine x. So the neg will just cancel with this and become positive. Sine x dx. And it's all of this subtract from e to the x sine x. Now remember, all of this from before equaled this integral, e to the x sine x. So now we have this big huge thing. So if you see, this is our integral. We actually have our same integral right here. So if we were to do integration by parts again, we'd basically just like have an infinite loop of these alternating integration by parts problems, and we'd never solve it because of the way trigonometric functions work. You get sine x, then cosine x, then neg sine x. But there's an easier way to solve it. Just simplify this part of the problem, e to the x sine x minus e to the x cosine x. Distribute the negative, so that's minus the integral of e to the x sine x dx equals this integral of e to the x sine x dx. This and this are the same thing, so just bring this to the other side. You get e to the x sine x minus e to the x cosine x equals 2 times the integral of e to the x sine x dx. I'm getting kind of messy here, so I'm going to open up another. So I'll just write that again. E to the x sine x, whoops, minus e to the x cosine x equals 2 times the integral of e to the x sine x dx. So now, in order to solve for this, all you have to do is divide both sides by 2. So the 2 cancels from there. You divide it by 2. And that's what your integral equals. You simplify it to e to the x times sine x minus cosine x all over 2. And that's our final answer. So I'll just run through it one more time. We started with this original problem, the integral of e to the x sine x. We did our normal integration by parts. We picked our u, we picked our dv, then we ended up with this. And then this was not finished because we had to do integration by parts again with the e to the x cosine x. So that's what we did over here. We did integration by parts for the second time. And we got our original integral back here, which is the same thing as this. So then we just brought it to this side and simplified, divide by 2, and we got this as our final answer. If you could do this problem, you could do just about any integration by parts problem.